grass seeds are elongated. And when I put a grass seed in an electric field, it will become polarized. There's nothing you can do about it. Here's a grass seed, and the electric field is like so. And so the electrons want to go as far away in this direction as they can through induction. And so this side remains positive. And so what is this grass seed going to do? It's going to rotate. It's going to line up with the electric field. And this is the way that I'm going to show you now field configurations in the vicinity of a dipole. And I will also show you then field configurations in the vicinity of two charges which have equal polarity. You may have seen this in high school with magnetic fields, with iron files. That's kid stuff. That's the easiest thing to do. This is the real thing. This is the electric fields. I bet you've never seen electric fields which are traced by these mysterious seeds. So I'll give you some light that may optimize the demonstration. These seeds first have to be oriented in a way so that it is chaos. The first thing you see is I'm going to make this, I believe it's going to be a dipole first, almost certain. So I'm going to charge one positive and charge the other negative, and then we'll see how these grass seeds will form each other. Watch closely. There you go. My goodness. That is a wonderful dipole field. Of course, we don't know which one is plus or minus because the grass seeds have no arrows on them. But you clearly see these incredible lines radially inwards or outwards on each one of the charges. And then you see these nice arcs in between. Who could see it easily? Okay, you got something worse for your $20,000 tuition. Put a little bit more charge on maybe. Very clear. And now, which is perhaps more interesting, I'd like to show you the field surrounding two charges, but now the charges are both the same polarity. So we have to undo the memory of the grass seeds. Okay, now we'll try to make them both the same polarity. And then watch this hair blower effect that I told you about. Maybe it will not make... I'm not sure they made contact. Okay, we'll try it again. Come on. It's very funny, you know. It looks like there is some charge hidden, because it doesn't look as beautiful as we had earlier on the Maxwell view graph. It seems like there is something here on the side which it prefers, and therefore the electric field is being distorted. Let me try to discharge it. I'm a reasonable conductor, so I should be able to take any straight charges off. Oh, wait a minute. Ha! I had it upside down. Oh, my goodness. Can happen to anyone. All right. So they were never really in good contact. We ready now? Ah, look at that. Great. Now, you really clearly see these field lines, and you see in between how the two air blowers are competing with each other. Very impressive. All right, so that's the way you see field lines now, electric field lines. And some of you may have seen with iron files, magnetic field lines. If I have the Van de Graaff, and I have the Van de Graaff here, and let's suppose the Van de Graaff is positive. I don't know whether it's positive or negative. Let's suppose it's going to use the one over there. And I'm going to stand here on the ground, Walter Lewin, what is going to happen with me? Through induction, the electrons being sucked out of the Earth and coming up because they want to go close to the positive charge. So I will become negatively charged. What will the field lines do? Oh, they will be extremely complicated. Very complicated. But something like this maybe. Maybe something like this. Some may come out here. Some may end up on my neck here. Some may go here. Like so. Very complicated field configurations. But I want to probe that field. Somehow, a little. Get a feeling for what that field is like. And the way I'm going to do that is I'm going to put a charged balloon. There you see the balloon. It's a conductor. I'm going to put a charged balloon and put it here, say. Well, if it is a positively charged balloon, it will take off in that direction. Right? The force is always tangential to the field lines. It will abandon the field lines. It won't stay on the field lines. There's a lot of damping on the balloon. That's why I chose a balloon. So it will move relatively slowly, and it will ultimately maybe add up on my head right here. Once it adds up on my head there, so it comes in maybe like this, now it will get the negative charge from my head, and so it will become immediately negatively charged, and so the force now will reverse and will be in this direction, tangential to this field line. And so it will go back. When it hits the Van de Graaff again, it will get positive charge. Reverses polarity, and it will go back. And so it will bounce back and forth between me and the Van de Graaff, and that gives you some rough feeling of what this field configuration is about, although I want to remind you that the charge does not follow exactly field lines. So I'm going to sit here, and I will be part of this. So that's probably going to be positive. I will automatically become negative. There's nothing I have to do. All I turn is the Van de Graaff, and we have to put a little bit of charge on that balloon. It will probably do that by itself, but I can always give it a little kick so that it goes through the Van de Graaff. There it goes. Oh, I had to... Because my glasses are a good insulator, so I better take my glasses off so that every time it hits me, changes polarity. So this is a way you can do physics and have fun at the same time. See you Monday.